Right, so yeah, I can see that we have participants from Jordan, from Kuwait, from Pakistan, from Egypt. Welcome everyone, and yeah, keep on telling us. You'll see that we have speakers, from also from many different countries. Okay, so I think it's time to start. So welcome to a webinar, how tracking technology is adapting to ultra high power modules in the Middle East and Africa. So today we'll have 4 expert speakers on this subject. So it's your chance to listen to them, to learn from them, and also to ask questions, which you can do using the Q&A box at the bottom of the toolbar. And right, so I think Valerie, if you can stop sharing your screen, and then we'll do a brief round of presentations. So if each of you can present themselves, so I'll do it in the order I can see you on the screen, guys. So Michael, could you please briefly introduce yourself?
Yeah, thanks, Carlos, and great to be here. So I'm Michael Corio. I'm the sales leader for international markets here at Array Technologies. Array Technologies is one of the oldest and largest manufacturers of solar tracking systems, and looking forward to talking about large format modules and the future, roadmap that we see from the tracking space. I'm calling in from Sydney, Australia as well.
Right, thank you very much, Michael. Himanshu, could you briefly introduce yourself, please?
Thank you, Carlos, for having us today here on this session. My name is Himanshu, and I'm the Director for Business Development at Nextracker. Nextracker, as you know, is the largest tracker supplier in the world today. And looking forward to discuss, the upcoming trends in the module space and how they're affecting our tracker designs. I'm today dialing in from India, our office in India.
Thank you very much, Himanshu. And Gonzalo, please.
Hi, Carlos. Hi, everybody. It is Gonzalo Carrasco. I'm Key Account Manager and Middle East and Africa focal points for Enclave. And well, I'm phoning from Madrid and looking forward to give everybody an overview of the developments that we are doing to cope with the bigger models that are coming into the market.
Thank you very much, Gonzalo. And last but definitely not least, Antonio.
Hi, hello everybody. This is Antonio Jimenez from Tria Solar from the Dubai office. I'm the head for Middle East and Africa, and here I'd like to introduce you the new high power modules and from Tria Solar, one of the largest PV companies in the world.
Thank you very much, Antonio. Well, I think you're the first one to present. So whenever you're ready, start sharing your screen. And in the meantime, I would just like to remind everyone that we will send you the slides and the video recording of this webinar. So you'll get it, in a couple of days' time in your inbox. So, all right, over to you, Antonio. Your microphone is on mute. So.
Now it's not on mute anymore.
Okay.
So thank you very much, Carlos. So good afternoon, and thank you for joining the session about ultra high powers and the integration with the trackers. But first, I would like to say some words about the company. Tria Solar is a global leader of PV and smart energy solutions, which means that we have gone from equipment supplier to be able to deliver solutions and much more. Tria Solar was founded in 1997, as you can see, and is not only one of the largest, but also the oldest company in the market. This is a guarantee of continuity because Tria Solar has remained while many others has gone. Also, since 2020, Tria Solar is listed in Shanghai Stock Index. And for the last 6 years, Tria Solar has been named the most bankable module brand according to Bloomberg. This shows the strength of the company and the bankability, which is important. But let's move into what we are introducing today. Tria Solar has introduced this year the Vertex series, which started in 500, and now we are introducing the 550 and the 600. These modules are made with cell of 2010 millimeters, which are the technology necessary to exceed 600 watts. This module we present in two options, either monofacial with backsheet or bifacial with double glass. The configuration of the 550 differs a little for the standard because it's a 155 half-cut cell, total 110, in a configuration of 5x11, while the 600 watts is a more traditional 120 cells, half-cut. So let's go a bit about the technical characteristic of the modules. These modules that we have brought to the market, one of the characteristics is that they are shorter than any other module above 500 watts. Why this is important? This is important because the forces on the tracker increases with the square of the width of the tracker. So the width, which is the length of the module. So the wider the tracker and the longer the module, the most important forces increase to the square. And shorter means that it is possible to use lighter tracker and less posts. So this means that the loads will be, or that the loads would be smaller and can stand bigger winds. So, and this is very important because we see that there are some voices in the market saying that bigger is not better. As we can see, we have not the biggest market, which we have the best. This voice also raised concerns about the mechanical load on the module. And we agree. There can be mechanical load problems, but not on our module for two reasons. One is the size, well, which I say, but the other two reasons are the frame size and the dual glass. So if we talk about the frame, the module of Tria Solar has increased the width of the frame with the width of the module, with the size of the module. For the 2.6 square meter 500 watt module, Tria Solar have increased the frame from 30, which we have in the very successful and well-proven 166 module, to 35 millimeters. Again, for the 600 watt module, which has 2.8 square meters, we increase again to 40 millimeters. The result is that this module passes successfully all the mechanical load tests, and even with less degradation than a conventional module. On the other side, which you can see on the right, we see that other companies that were using 40 millimeter for the 460 watts, now they come with a smaller frame, a thinner frame. So either, I don't know, that is where we think that the rumors came to the market. And it's natural that the advisor raised this question, but we don't see that in our model. The second point is the double glass. Tria Solar sets the cells between two glasses of 2 millimeters each. This way, the cells are protected both mechanically and chemically. On the chemical side, which just a remark, the double glass prevents excess of humidity and any other chemical vapor, salts, anything. This is something that not a single backsheet is able to achieve. But on the mechanical side, which is, I think, the main topic today, the cell is supported on both sides. This means that whenever it's bending, there is no flexing stress. No flexing stress, less problem with micro cracks, and this is very especially important when it's installed on a tracker, which is because the tracker is subject, the modules are subject to torsion and to vibration. Also, all the problem during the transportation and installation. So this is something that the double glass, which holds very well the cell, helps to solve. Also, we are talking that most utility projects will be bifacial. This means that at certain point during the 30 years of life, you will have to clean the backside. So having a glass means that you will not damage the cell damage the cell, which is something that any backsheet can achieve. And finally, the 2 times 2 millimeter helps to improve the mechanical load. So we are able to have thinner frame than when we are using a single glass, and this applies to everyone. So this is a module that stands very well the mechanical load. If we move inside the problem of micro cracks, what we have is half cut cell with the technique of non-destructive cutting, which is a low temperature, non-mechanical procedure that leaves the edge of the cells very smooth. So if you see here the picture, a standard traditional cutting will leave some spikes, some rough texture that lead to micro cracks or have a higher tendency into micro cracks. With this new technique, the surface is smooth, and what is the result? That the mechanical performance of the cell is similar to a non-cut full cell. So we say yes, may concern, but with this technique, with this double glass, doesn't happen. The following is the cells. How we place the cell? We place the cells very close together, which is less than half a millimeter compared with the 2 millimeter of conventional modules, but with no overlapping. So with this technology, we are able to reach same or even better efficiency than overlap modules. And the reason is that when you overlap the cells, there will be shadowing on one on top of the other, which will reduce the power of the module. In addition, what we see is that the areas which are overlapped tend to have micro cracks due to the thermal stress during the heating during the day, cooling down during the night. So we see that it's a technology that doesn't apport benefits, but will give risk for the long term, or at least concern for the long-term behavior. And finally, let's talk about the second most important load for the tracker after the wing, which is the weight of the module. The weight of the module, which lighter module means lighter tracker. In this regard, Tria Solar designs the lightest modules by any metric. If we see the back sheet, either by watts per kilogram or kilogram per square meter, we see that we are lighter than any comparable module above 500 watts. If we go to double glass, the same. We are the lighter. The question is that we see some comparison between double glass and back sheet, which are not right. You have seen the benefits of the double glass. Now you see that these benefits come with additional weights of approximately 10%, 1.2. If you compare our weight per square meter of the double glass with the competition weight of the back sheet, is around 1.2 kilos, around 10%. This has an influence, but more or less influence that the length of the module. So you will see that at the end, the influence of the module, the weight, is less than the force due to the wing, plus all the benefit of having the double glass, chemically, micro cracks, and everything. So we think that it's a much better solution to go for a double glass with us than any other competition. But let's see, this is not the only big advantage that has the Vertex. The following is the key one: low voltage, high string power. What does it mean? This means that we can do strings of 20 kilowatts and above. This is 35 or more % than what you can do with another module above 500 watts. I mean, we are talking about 500 watts and beyond, the latest generation. So we can have more power. And this has a benefit in the BOS on the plant by 2 ways. Either you will install less tracker, which is something that we have here three important guests that they can present, or they will present, or you will have savings because you will start certainly less strings. But at the end, they will come with savings. And this is very important because on the way forward, what you will need is to keep lowering the price of electricity. And this is the way forward. There is an alliance of more than 60 companies that they have come together to develop this. I say this is the future. So please finish. If you have any question, please, you have here the address to reach us, and we are happy to answer any questions. Thank you very much.
Thank you very much, Antonio, for your presentation. Very interesting. I think if you can stop sharing your screen so the next speaker, who is Gonzalo, can share his. Thank you very much. So yeah, Gonzalo, it's your turn. And well, so always remember, we are recording this, and we'll send you the recording and the slides. And don't forget to ask questions. So the Q&A box is there for you to ask questions. And yeah, Gonzalo, over to you.
Okay, hi everybody. So well, I'm going to make a very quick introduction of the company, presenting part of our portfolio, and then talk about those modifications or adaptations that we had to make in the tracker in order to cope with the new models in the market. So well, very briefly, so Enclave was born by the merge of two Spanish companies with very extensive solar PV tracker experience, and currently we are 100% owned by Tria Solar. We have been in the market since 2005, and well, we offer customized solutions. We cover the entire tracker value chain from research and development to maintenance. And I always like to say that we have the widest portfolio in the market, as we have fixed structure, multi-row, bi-row, single row. And well, thanks to this, right now we are fourth, fifth tracker manufacturer in the world. Currently, we have more than 5.44 gigawatts, and well, at this stage, we are increasing sales in APAC and USA, and maintaining those markets that are traditionally strong for Enclave, which are Europe and Latin America, South America. And we're in Middle East and Africa. We are already present in several countries like Kenya, Burkina Faso, Tunisia, South Africa, and also in Jordan. And we are currently closing deals to set manufacturing facilities in KSA and South Africa, in order to be able to offer local content to our clients there. So well, below you have some of our clients. As you can see, all of them are very big companies, utilities that are present around the world. So I'm not going to present the full portfolio, but the two main trackers that we are well commercializing and using in the area, which are the SP160 Litha. This is a 2P configuration, single row, and this tracker is already designed to support larger models. So what we have done is we have increased the amount of drives that we are using. So we are using a multi-drive system with a central drive and 2 on every each, sometimes even 4 in total per tracker, depending on location. And one of the main benefits of this tracker is that we have fewer piles than other solutions. We are looking around 100 piles with a 600 watt peak model, which, I mean, everybody can imagine the impact that this have in a terrain where concrete foundations are needed. And then we also have the SP240 Suna, which is, well, the by-row solution. Initially, we had a SP1000, which could have up to 18 rows, and we have combined the benefit of fewer rows and the multi-row in order to create the every-row solution. And this tracker is especially designed for those areas with very heavy loads coming from wind or snow. So, well, getting into the main topic, this is our view of how the market has been changing and evolving along these years. So the reality is that the PV plants and adapt to the changes that the module manufacturer do in the module as it is the main component of the PV plant. So if we look here in the top of the slide, we can see how changes in the voltage DC of the plant, changes in the cell size, amount of cells per module. All these changes have been pushing the size of the module up. Like in 2011, we were, I don't know, using 12 modules per string, and we were looking at 1.88 square meters per module. And today we are installing 36 modules per string with double the size in the model that we had, I don't know, 5 years ago, 7 years ago. So obviously, I mean, if we look at this, this is pushing and the tracker to be stronger as it has to support higher loads. So what we have done and looking into detail on how the modifications of the tracker of the module, sorry, impact on the tracker, we have created this slide where we see that when the module increase the length, the tracker, the effect is higher cord length and affecting dynamic properties. So the same with width and the dynamic properties, tracker length, and then the amount of modules per string, which also increases the tracker length. So in order to make a reliable tracker and being able to support the higher loads, we have no option than, well, increasing tubes, purlins, and pile sections. Sometimes even increase the amount of piles per tracker, because that's the only option. And also something very important that is really having an impact on the tracker is the purling, which is the connection between the module and the torque tube. This is increasing in, well, thicker profiles. It might even need to be longer in those trackers where the stow position has a very high tilt, which obviously have an impact in the cost of the tracker. So if we look at more specific changes that we have done in our trackers, the main change in the SP100, the 2P configuration, is the improved drive system, multi-drive point. We really believe this is the way forward in the 2P configurations, and we see that other competitors are also moving towards this direction. So this increased natural frequency of the tracker, high accuracy, and high stability. We have also changed the bearings, heavier loads and steeper slopes, and increase the torque tube dimension. This is important because is one of the main components of the tracker by increasing the dimensions. In one of our solutions, we have moved from 150 by 150 to 170 by 170. We are giving extra stiffness to the tracker, which will avoid any possibility of aeroelastic effect. And then, well, we have also increased the motor power, and we are also changing some of our piles in order to cope with higher loads in those specific piles where the loads are heavier, like motor piles. We are moving towards IPE or W profiles. And then, well, as I was mentioning, also the reinforced purlin. And last but definitely not least, I would even say it is the key to be able to cope with the new module sizes is a new wind tunnel test. I mean, we started a new wind tunnel test for the 2P configuration last year. We knew that larger modules were coming thanks to our, well, after all, we are part of Tria, so we have a very clear roadmap of the module market. So we have performed a new wind tunnel test, analyzing well pressure model, wind tunnel test, 2D sectional model test, 3D flat air stability analysis, and 3D buffeting response analysis. So this is already done for the 2P solution with RWDI. And I believe something important, we are probably, or the only company I know that is working with both RWDI and CPP. We are currently doing a new wind tunnel test for larger modules with CPP for the 1P configuration, which should be available by December, maybe January. So considering this, the conclusions are quite straightforward with what I have been mentioning. Definitely the loads are bigger in the tracker due to the bigger surface of the modules. However, this is something that it is not a problem as long as there is studies, wind tunnel test, and engineering behind the tracker. And well, it's something that Enclave has done, and we are now looking at our solution with trackers of approximately 70 meters length and up to 36 moles per string, depending on the specific wind loads and conditions. So yes, definitely models are impacting in the tracker, but definitely it is the way forward because of the benefits in the LCOE in the plants. So that's all from my side. Thank you very much for your attention, and yeah, I will be available for questions.
Thank you very much, Gonzalo, for your presentation. I can see that there are some questions on the Q&A box, but I encourage all of you to think, if you have a question, and well, if you do, post it there on the Q&A box. And next up, we have Himanshu. Himanshu, if you can get ready and start sharing your screen whenever you are ready.
Thank you, Carlos.
You're welcome. So yeah, I can see the presentation, full screen, perfect. Over to you, Himanshu.
So first, let me begin by thanking Tria Solar and ATA team for inviting us to this webinar session. As you can see, a very nice image of Nextracker's installation in Saudi Arabia for the 105 megawatt project in Saudi Arabia, Sakaka. Let me take a step back and talk about how we've been partnering with Tria. We have been working with Trina Solar for a lot of projects between Nextracker and Trina Solar, set up worldwide, multiple gigawatts of those. So we obviously have a very strong collaboration on the module spacing with Trina Solar, and I'm looking forward to supporting all these upcoming newer module technologies that are helping innovate the offerings that come up for future power plants. Let me take a step here and give a quick overview about the company. As we see today, Nextracker has about 40 gigawatts of solar tracker installations or under constructions since it's set up about 6 years back in 2013. So that makes us the largest tracker supplier in the world today, with a roughly about 32% market share in 2019 in megawatt terms. Pretty much the same market share over the last 5 years. In terms of our company profile, we are a 100% subsidiary of Flex, a $25 billion corporation listed on the NASDAQ stock exchange, and with presence in multiple countries across the world. So that gives us a very wide landscape of operation, where we can address to a lot of markets worldwide. Nextracker itself has about 8 global offices with our headquarter office in Fremont. And our product lines, which I will cover in subsequent slides, we are primarily a tracker supplier and also offer software and controls systems for those trackers. We have a very experienced team, having a lot of experience in actually doing the EPCs and also in development of projects across the world. And that plays out a very important role in our landscape and how we think from the end customer's perspective on how to address the concerns of the developers and the EPCs on projects that they are building. So that's where we come from. A quick snapshot of where Nextracker stands in the Middle East, North Africa region. We maintain a healthy 30% market share here, very similar to our global market share. And key regions that we operate are are Saudi Arabia, UAE, Jordan, Egypt, and Oman. We also have a significant presence now in the African continent with projects in Kenya and other locations. Very recently, I'm pleased to report Nextracker was selected for the Deva 5 1 gigawatt project in Dubai, being developed by Aqua Power and Shanghai Electric being the EPC there. So that's a very recent development that you would see. Coming to our focus on the Middle East, Europe, and North Africa markets, so we anticipate that this is one of the fastest growing regions in the world outside of United States, roughly touching about 60 gigawatts of capacity by 2024. So that makes it a key enabler for the tracker demand worldwide. This is a strategic market from a tracker perspective. Obviously, we think UAE and Saudi Arabia are going to play a key role here. They have the largest projects coming in the region, and all the upcoming projects pretty much the larger size here. So that's the key importance of the region that we emphasize on. We have a very strong customer base in the region, a lot of repeat customers who have been working with Nextracker and giving us multiple projects to work on. Coming back to Trina, so as we talked about, since 2013, we have done quite a few gigawatts of projects with the Trina modules, and we are looking to further enhance that partnership in ensuring complete compatibility with the upcoming module series from Trina, the Vortex 550 and the 600 watt peak. So let me give you a quick snapshot now about our core offerings and how these offerings are aligned to these upcoming module series. What you can see on your left-hand side are our tracker offerings. We have two tracker offerings, the NX Horizon, which is our legacy product launched about 6 years back. And it's a one-in-portrait configuration independent row design. The second picture on that you see there is the NX Gemini, which is the 2-in-portrait configuration, which was launched about a year back to address to specific market requirements, specifically, hard soils or undulating sites. So those are some of the areas where, we look at Gemini. Apart from this, we also have a lot of software and control systems offering, which actually enable us to do detailed monitoring and improve the overall yield of the power plants. I will touch about one of these as we speak about the larger modules and how these help those. Now, one of the things that we have been discussing about in this session is about the increased length and sizes of these modules. Just to give a quick overview here on our topic, way back 2015, we had module ranging from 325, 330s with roughly now going to 600 plus watt peak. One of the things that we are seeing now is the increase in the surface area, right? So the length, the width are increasing, and obviously from a structure design, a tracker design perspective, we really need to understand the forces that are acting on these modules, on the structures, to be able to efficiently design products for those. So let me walk through some of the steps that Nextracker is actually doing right now to address the larger module formats that we are seeing. Let's start with the active wind stowing. So one of the things that we see is with the size of the modules, obviously the pressure acting on the panels is increasing. And one of the ways to optimize that is to look at active wind stowing, which is really to stow into the direction of the wind so that the front side of the module is actually facing the wind. That actually helps in reducing some panel pressures, as well as ensuring that there is no backwinding of the panel happening, thus minimizing the risk of any micro cracking at post installation. Some of my colleagues today covered rightly that engineering needs to be done. We need to analyze from a wind dynamics perspective on eliminating some of the impacts that dynamic winds can cause. And this becomes critical because these effects like galloping or fluttering not only happen at the design wind speed or higher, but they can even happen at lower wind speeds. And so the overall system design here becomes very critical. So definitely doing a dynamic wind analysis is really critical with these larger form factor modules. In sites where we see hail also plays a very tough role, especially as the sizes become bigger. Then we need to design the structures for those. We also undertake a very detailed wind pressure mapping of the site whenever we do layouts with these bigger modules, and that helps us optimize our design between exterior and interior rows. Maybe lower foundations on interior versus exterior, or lighter parts on interior versus exterior. So that kind of optimization works continues. Lastly, we also look at the installation ease. Obviously the panels getting heavier, it creates additional load on the installation workforce about lifting them. With the bifacial, we want them to be higher above ground, but also look at the overall ease of installation. So we also look at those aspects and design the tracker, the optimal height for designing the trackers that we need to look at. Let me quickly give you a quick glance through of some of the effects that Nextracker is already undertaking. We have actually completed the wind tunnel testing for the larger format modules with the CPP. So that is something that we are already ready with. And what you see is a visualization of some of those tests. How these wind tunnel tests actually demonstrate the loads and the forces acting on the module, especially on these larger ones. Also, the dynamic analysis, it's not just one step analysis, but it's a very detailed analysis that takes into consideration multiple dynamic modes that act on the modules. And with the larger modules, obviously we expect that those factors will be amplified. So there's a lot of emphasis being paid out to the overall stability of the structure, and ensuring that the structure designs are actually robust enough to ensure compliance with the bigger modules. One of the things I talked about at the start was about the active stowing and control. So here is a good example. Previously, stowing was just based on the speed of the wind. Now what we constantly look at is both the speed and the direction of the wind, and depending upon that, the modules are directed to stow into the direction of the wind. What this does is really it minimizes the instability that the module will face, as well as it will prevent the micro cracking on the module. So with the bigger size module, those effects become pretty important to ensure the overall performance of the module. We continue to support the bigger size modules with the TrueCapture smart control systems. For those of you who are new, so we offer the TrueCapture smart control systems, which has two broad components. One is the road-to-road tracking, which basically helps eliminate inter-row shading. So normal tracking algorithms, assume that the whole site is really flat, and just direct the rows to be perpendicular or tangent to the sun. With TrueCapture, we actually consider the site undulations, the differences in the pitch between the rows, and then real-time adjust the tracking angles of a row to minimize the shading, especially during the early morning and late evening backtracking hours. So that eliminates those losses and actually enhances the generation of the power plant. The second aspect is the diffuse light tracking, where in a diffuse light condition, cloudy day or where there's dust in the air. So instead of being normal to the sun, if we can have the modules to be flatter or near flat angles, then we capture more isotropic radiation. So that would actually help us capture additional gains. And we can see anywhere up to 6% gains with these smart control systems. We continue to support with the bifacial features on the larger module formats. Excuse me. Which is, we have the high-rise module rail, which creates roughly about a 90 mm gap between their backside top tube and the module. That eliminates the shading on the backside of the panel. We also have the gaps at the piers as well as at the drive systems in the horizon platform. And what this does is it allows, because you don't have any of these parts which are shading on the backside of the module, so they minimize the shading effects for the bifacial product, and help to enhance the yield of the plant by anywhere around 1 to 1.5%. We have a lot of additional resources on our website, which I would direct the participants today on quantifying the bifacial, and all of this is really applicable to the wider modules that we see coming into the market. With that, I pass it back to you, Carlos. Thank you for the opportunity.
Thank you very much, Himanshu, for your presentation. So I've had a few people ask me if we'll send them the slides, and yes, we will. We'll send you an email. Will you get the presentation slides and the video recording? So don't worry about it. And then, well, I think now is your turn, Michael.
Yeah, thanks, Carlos, and a big thank you to Tria and ATA Insights for inviting Array Technologies to join. So I'm going to share my screen here. So thanks for everyone for joining. My name is Michael Corio. I'm the sales leader for international markets for Array Technologies. And I'll be introducing you to the company and our tracking system, as well as talking about the future of integrating larger format modules into our platform. So Array Technologies is one of the oldest and largest tracker manufacturers in the world. We've been making tracking systems for over 30 years. So our first Duratrax version 1 system was deployed on a site in Alamosa, Colorado in 2006. It was a 6 megawatt project, which, if you can believe it, was the largest solar project in the US at the time, and also the first 1,000 volt system in the US. Since our first version 1 system, we've gone on to deploy over 22 gigawatts of our product around the world. And we're currently on the Duratrax version 3 product, which, really we've developed over decades of experimentation and trying out different tracking technologies. And so we've had a long runway to really develop our solutions to larger format modules, as well as, the changing trends in the industry. Generally, we've had a very strong presence in our home market of North America, where the company is located in Albuquerque, New Mexico. But since then, we've expanded our presence around the world. I'm currently based here in Sydney, Australia, but we've opened up offices across Europe, Latin America, Dubai, and many other locations. And, certainly we're looking to the future, and we can tell that solar energy is going to be a mega trend for the next 50 years. And in order to be successful as a tracking company, we need to anticipate what's coming down the track in the future and adapt to changing trends. So there are a few aspects that really motivate our design innovation. We're one of the only tracking companies that have had our systems operational in the ground for over 11 years. We all know with the tracking system that it has to be competitive at the front end. That much is clear. But tracking systems need to accomplish a number of other important things. They need to have an efficient use of the land, maximize power density, and maximize production by fitting more power into the same amount of land, or being able to spread out the rows and reduce backtracking. Tracking systems need to be able to follow terrain. So, for example, our Duratrax system can go up to 40 degrees in the east-west direction and up to 26 degrees in the north-south, because we know civil works and grading are quite a big expense when building a solar farm. Here at Array Technologies, we've had a very different approach to tracking systems. We believe that the more electronics, batteries, motors that a system has, the less reliable it will be over the 30-year life of the asset. And generally, the more maintenance that you'll have to expend across a system. Because relatively, if you look at a solar tracking system, it really comes down to the number of failure points in the system. So, our philosophy has been not to use batteries, to eliminate electronics wherever possible, and find simple mechanical solutions that'll be robust and last and work well over the next 30 years. For example, we only have about 150 motors and controllers for a 100 megawatt DC site, and many other distributed tracking systems on the market that you see, can have up to 25,000 batteries, motors, and electromechanical components. So it's something we do a bit differently. Additionally, we're the only tracking system on the market that doesn't use active electrical stowing systems to protect the tracker in a windstorm. We've developed a fully passive mechanical wind relief mechanism that doesn't rely on batteries or electricities to protect your site every time there's a windstorm. And it has a fully passive and mechanical way of reacting to the wind that just ensures your tracking system will be safe at any tracking angle. And it doesn't need to rely on other devices to protect your asset in a windstorm. Finally, really our goal at Array Technologies is to deliver a solution that will have a low O&M profile and high reliability over the life of the asset. So in our version 3 Duratrax system, we've developed a product that has zero scheduled maintenance. There's no greasing of the gearboxes or motors required. Of course, we don't use electrical stow, so there's no need to test for that functionality. And we use self-locking hardware across all of our fasteners, so that under wind loading conditions, fasteners and that kind of thing can't become loose over time. Again, these are things we've learned over decades of building tracking systems, and we're quite proud of the technology we've developed to really deliver the lowest LCOE, levelized cost of energy for your power plant. So here are a few pictures of our unique architecture. So we have a patented design that's quite different from many other systems in the market. We have what's called a linked flexible rotating driveline design. So you can see here on the right a picture of our driveline. Essentially what this is a motor over here on the left sits on the edge of a tracker block. It transfers a rotational movement through one-way gearboxes that are located at the center of every row. And we connect up to 32 rows of up to 120 modules per row. And all of that is driven by a single motor. So in essence, we drive about a megawatt DC of power with a single motor. But what makes us different from many other linked systems is these lightweight, flexible row-to-row connections have a high degree of terrain flexibility. So by incorporating these articulating U-joints into either end of the row-to-row driveline, we can go up, down, left, and right in a 40-degree cone, essentially 40 degrees in the east-west direction, so we can follow undulating hills. We can stagger the rows to accommodate irregular site boundaries. But the major benefit is we only have one motor per megawatt DC. And one controller controls about 6 megawatts DC or 6 motors. So the O&M profile on our system is vastly reduced by minimizing the number of potential failure points, which in our experience, we found to be the electromechanical components on a tracker. We've put a lot of innovation into this product. We have unique single bolt module clamps with integrating grounding clips, which allow for rapid module installation, as well as building things like flexible tolerances into the bearing column caps, and having less than half the number of fasteners than our closest competitor. So all of these things really play into delivering a system that's low cost to install and low maintenance, and doesn't require many resources to maintain over the life of the asset. So now I'd like to switch gears. I've introduced you a little bit to our Duratrax system, and I'd like to talk about today's topic, which is large format modules and the future of integrating these modules with tracking systems. So we know that from a tracker perspective, the increasing efficiencies of modules have the biggest direct impact on driving down our costs. As modules get more efficient, essentially you need less and less tracking system to generate the same amount of power. It's interesting, seeing the trend with these larger format modules in the market. We're starting to see a number of factors come together that require some innovative thinking and, looking at the trade-offs between things like number of foundations and types of clamping solutions needed, to hold these larger modules in place, as well as the potential to, offer extended module row designs and innovate on the number of modules per row that we can achieve. So, what I really like about the Tria modules that we saw earlier in the presentation is things like, the reduced weight of the module, the fact that Tria is taking the step to have a 35 millimeter frame instead of going the opposite direction, towards a 25 millimeter frame. Those kind of things really help integrate those modules onto a tracking system and help us achieve, the most cost-effective design from a tracker perspective. Because at the end of the day, you really want an integrated solution that makes sense. So you can't look at the module in isolation or the tracking system in isolation. You need to see, the total configuration and solution together. So, the lower the weight, the weight of a module is, the longer the rows we can design, which obviously is good because the more modules we can put on a row, the fewer foundations per module we have, and the more power per row we can generate. But of course, like anything in life, there are a number of trade-offs. So, one thing with larger format modules is as they get bigger, the surface area of the tracking system increases. the more surface area you have on a tracking system, the higher your wind pressures will be, and the more challenging it becomes to integrate these larger format modules into a tracker. Array Technologies, primarily for this reason, offers a one-in-portrait design, which we believe to be more cost-effective from an installation standpoint, as well as a structural suitability standpoint, with these modules that are getting longer and bigger and heavier. But one thing, we've found is it really depends on the site-specific conditions that you're faced with. If you're in a high wind speed zone, the pressures on a larger format module present a bigger challenge. We may need to add more foundations to a tracker road depending on the wind speed. Again, going back to the frame thickness, the thinner the module frame is, the more structural clamping we're going to need to make up for the lack of a frame. And generally, we find that modules that are below a 35 millimeter frame, in a large format style, presents a number of challenges, especially in these high wind speed zones. So again, it comes down to knowing the site very well and figuring out what types of clamps are suitable for a particular wind speed and the particular site conditions. So here at Array Technologies, we have a number of different custom clamping solutions that we will deploy based on those factors. So we have, a 300, 400, 600, 1,000 millimeter clamping set. We have through bolt solutions. We have different rail designs, and we may deploy a heavier clamping solution on some exterior rows in order to, deploy a less expensive clamping solution on interior rows that may not receive as much wind pressure. So it's a highly customizable exercise. Now, just to kind of put a bookend on that point, really, what I like about the Trina modules is we're able to achieve quite interesting extended module row designs. So we can go out to about 130 meters on a single row. So for example, the Trina Vertex DE19 series, we can do 111 modules per row. That's 3 strings of up to 37 modules per string. Same with the DE20 series. We can go up to 96 modules per row, 3 strings of up to 32. Again, a big reason for this is the fact that we have a good frame we can clamp to. The modules themselves are a decent weight and quite manageable to offer these extended row designs. Because, the more extended rows we can offer, we're just maximizing the watts generated per meter of tracker. And so we always look to see what is the most efficient use of the tracking system that we can utilize, because the more modules we can drive with a single motor, the fewer rows we have, the more cost effective it is for our customers. So that's pretty much the end of my presentation. And again, thank you to Trina and ATA Insights for inviting us to join.
Thank you very much, Michael, for your presentation. So, well, we've kind of come out to the end of the hour, but if you all agree, we can have a short Q&A session, 5 minutes or so. Yeah, okay, good. So, well, and thank you to everyone who's been watching us for the last hour. I hope that you found it insightful. So, right, so let's start with the first question. There is a question here about what kind of conditions the question says, what kind of wind tunnel free stream conditions are the modules tested at? I don't know who wants to take that question first.
Carlos, can you repeat that, please?
The question reads, on the which tunnel free stream conditions, on the what kind of wind tunnel free stream conditions are the modules tested at?
I'm not sure if I get the question correctly though.
Well, I suppose that you test the modules. First of all, do you test the modules on a wind tunnel? And if you do, what are the conditions for that?
So there are extensive level of testing that goes on. It's not like a one day or a one event test. There's a lot of configurations that get tested there. So it's not like, just this configuration is tested. So it's not like a simple answer, but I would encourage the user to reach out to us and, maybe we can have a separate technical session on really what goes into the wind tunnel testing.
Oh, right. Okay, good. So, well, so let's go to the next question. There is a question about static load issues. So the question reads, how do you improve or solve static load issues due to enlargement of the dimensions of the PV module? I think that's a question for Trina.
Oh, yes, thank you. So I think that it's a bit answered before. There are three important parts that, well, static it will be two, because the third will be the size, because it will be the wind load. But there are two parts which really help to improve the performance of the module with static loads. One is the frame size, that we have make it wider with the increased size of the module. So it really helps to prevent any bending, any deformation. The other is the double glass. The double glass really helps to optimize the width. So together, the resistance of the module, the static load, is very good. What the test we have seen shows that this degradation test is that they measure the power, they have some loads for some time, and then they measure again to see the degradation due to micro cracks and other reasons. And we see that the performance of the module is much better than any other the performance of this module on the mechanical load test is much better than any other module that we have seen.
I was on mute. So thank you. There is another question for Trina, which is, do longer strings increase the price of trackers?
From my point of view, they don't increase, otherwise they reduce, because it is possible to install more power on each tracker, and it reduces the number of purlins, and it reduces the overall BOS of the system. But this is from the point of view of the module. I think that is also something that the tracker manufacturer must have a say.
I can take a shot at that one from a tracker perspective. So that is correct. It really is about how many modules can you fit into the tracker row. That's what really governing. So obviously, the more modules you can have in a given row, obviously that is best, because then you are optimizing the controllers, the gears, the motors on the row. So typically, if you go to more number of modules in the row, definitely it's going to be more cost optimal for the tracker perspective.
Thank you, Himanshu. I think, Gonzalo, you wanted to say something.
Yeah, it is in the same line than Himanshu was answering. I mean, the higher amount of models that you can fit in the tracker, after all, you will reduce the amount of trackers per PV plant, and that will optimize cost. So I think it is a very good solution that Trina is showcasing to the market.
Thank you. And well, let's go with the final question, because we're already over time. And someone is asking from Innovation SB Energy if there is a roadmap for a tracker cost reduction in bifacial, the he's talking about the trackers that you would use for bifacial modules. So is there an idea of how the costs might be reduced?
I'll take a stab at that one. So, I mean, clearly, I think we're always trying to reduce cost and constantly innovate on the supply chain side and also on the product side to get more efficiencies, to increase the length of the rows, and achieve a lower cost. Particularly with bifacial, it's quite interesting. We obviously see a gain on the backside of a bifacial panel versus a traditional monofacial panel. For example, we've developed special high-rise clamps that elevate bifacial modules at an optimal height above the torque tube to allow for maximum generation. And we've also released something called Smart Track, which has a number of optimized algorithms, one to adjust for terrain following and reduce any potential variations in terrain across a motor block, a diffuse light algorithm as well, but the third is actually an optimized bifacial algorithm that has a different backtracking functionality to maximize the gain from the backside of the panel. In my view, I think most of our projects going forward are going to be bifacial, and it's important to deploy, specialized clamping solutions and take into account things like the height of the tracker off the ground to maximize that gain and increase production and reduce cost.
Thank you very much, Michael. So, well, I think we have come to the end of this webinar. So I'd like to thank everyone, all the speakers and everyone in the audience as well who's been here with us for the last hour. So we will send you the slides of what they delivered today and also the recording of this webinar. And well, if you like this kind of webinar, go to ATA Insights and you'll find more. Yeah, well, thank you very much, and see you here next time.